Okay, we're recording.
All right. Hello, everyone, and welcome to our second day of the Hudson Valley Value-Added Grain School. We've got a great lineup for you today. So our agenda today, we're starting at 11, and then we'll go till noon. We'll have a lunch break from noon to 1. There will be some safety videos that will be shown during that. So, grab some lunch and watch the videos, and then we'll continue again in the afternoon with the presentations on heritage corn and small grain varieties and ancient and heritage. So with that, I will turn it over to Aaron Gabriel.
All right. Good morning, everyone. I'm pleased to introduce Shawn Shouse. Shawn is a field agricultural engineer for University Extension. He covers 21 counties in Southwest Iowa. He has a bachelor and master's degree from Iowa State University. Grain storage education is one of his main hobbies. He has a great blog on the ISU Integrated Crop Management site with several excellent articles on grain storage and management throughout the year. So with that, Shawn, I'll let you take it away.
Okay, thank you so much, Aaron. Welcome, everyone. Thanks for being here. I'll share my screen here and we'll see if we can get the presentation up and running. Here we go. So what we'd like to run through today is what I would call kind of my top 10 points that I think above average grain storage managers take care of. So the things that we'll run through here quickly are things that I think everyone should try to do if they're managing grain. And the top 10 that I chose here: know their system limitations, minimize grain damage in multiple locations through that chain of custody, understand allowable storage time and what that means and how that limits the options for storage, use wet holding effectively if they're drying grain, understand their drying system and how it operates and how they can best manage it, coring bins, which you heard mentioned last week, controlling grain temperature, that's a critical part of managing grain that's in storage, monitoring grain in storage, which seems like a given, but it's amazing how little of that actually happens, and actively managing for safety and having a backup plan for when things don't go the way you expect. So looking at your grain system limitations, we think that everyone needs to ask the questions: can I dry grain without heat? For corn in Iowa, and I think in New York as well, most years you can probably dry successfully up to about 22% moisture content corn without added heat. That's based on Albany weather being pretty similar to central Iowa. I need to ask, do I have enough airflow for drying or cooling? So you need to know the performance of the fans that you have on your grain storage bins or other containers. And we'll talk about how to estimate that if you don't know what that is. And do I have sufficient system capacity? Where are the bottlenecks in my system? And what can I do to work around some of those bottlenecks? The Grain Drying, Handling, and Storage Handbook from Midwest Plant Service has an excellent procedure for estimating bottlenecks in your transport system. So here you would put in the size of your harvest capacity, the size of wagons or trucks that you're hauling with, the haul distance, and then it would output for you the size of receiving pit that you might want to have and the unloading conveyor to try to minimize the waiting time and the bottlenecks that can come with transporting grain. In a similar way, you should be looking at your drying system and see, can my drying system keep up with my harvest capacity? If not, there are ways that you can work around that by adding some wet storage capacity, by modifying your grain drying system to make use of in-bin cooling, or possibly dry aeration, which we'll talk about, or possibly combination drying to increase that drying capacity. You can also use automation to allow the dryer to operate longer hours per day, and remote monitoring can make you more comfortable with that remote operation or extended operation through automation. Looking at your conveyors in your system as limitations, you need to size conveyors for the capacity that you need. If you have batch systems like a batch dryer, then you need high capacity conveyors so that you don't have to spend a lot of time waiting for things to load and unload. If you have continuous flow drying systems, then you can use a smaller capacity conveyor that's matched just to the continuous flow capacity coming out of and into the drying system. Remember that if you have multiple conveyors in series, each downstream conveyor should have 10 to 15% more capacity than the one feeding it so that you don't overload a downstream conveyor. And be aware that there are inefficiencies and damage that can be caused if you have conveyors, especially pneumatic conveyors and auger conveyors running at partial capacity. So those need to be running as close to full as possible. We'll talk about damage here for a minute. We want to look at damage before harvest by controlling insect damage in the field, damage during harvest, and you heard Matt mention this last week about watching the grain quality coming in and making sure that combine settings are adjusted so that you're not having excessive damage in the combine. And then you need to be watching for damage in conveying and in drying and storage, which we'll talk about later. Why is that damage important? When you look at the factors that can affect grain storage, down here we have two of them. Damaged grain, either damaged mechanically or by insects, opens up the seed coat that protects that inner portion of the seed and allows more easy access for insects and molds to attack that. And also the foreign material and fines that are generated by grain damage can reduce airflow in storage where we're trying to cool and maintain grain, and also serve as insect food for those insects that don't bore into the grain, will eat those fine materials. So in conveying, when we talk about damage, the capacity of conveyors affects the efficiency of the conveyor, how well you're filling that conveyor. But for two types of conveyors, augers and pneumatic conveyors, both the efficiency and the potential damage are affected by how well you load the conveyor. So for those two types of conveyors, make sure you run them near their rated capacity. For augers, keep those intakes submerged and change the auger size or speed if it doesn't match the capacity that you need. There's excessive wear that can be caused in the conveyors, and if there's excessive wear in an auger, that then can lead to excessive grain damage from the auger. Sorry about that background noise there. We want to talk about allowable storage time. Allowable storage time is the length of time that grain can be stored at a certain moisture content and temperature before it loses one quality grade, or about 0.5% of dry matter loss. That allowable storage time is usually published in tables. And so here's an example of the allowable storage time for corn, shelled corn. And you can see if you go in at a certain temperature and moisture content, for example, if we were harvesting at 55-degree grain and had a moisture content of about 24%, the allowable storage time for that corn would be about 17 days before it has lost a quality grade, or about 0.5% of dry matter. If we were out there when the temperature was higher, say 75 degrees, the allowable storage time at that moisture content would only be 5 days. And so we only want to use up about half of our allowable storage time while we have custody of the grain, leaving some error margin there and some allowable storage time on down the transportation chain. But that temperature makes a huge difference on how long we can store that grain. So in the drying chain, it can help us considerably to match our harvest capacity with our dryer capacity if we have some wet storage built in, some wet holding capacity. So what we do here is just add a storage tank between the harvest and the dryer. This allows the dryer to operate when we aren't able to keep feeding it directly from harvest. So those tanks need to be a first in, first out kind of tank. So hopper bottom tanks work well, or even a flat bottom tank if you put a cone of dry grain in it first so that all the wet grain is still coming first in, first out. It takes a tall, slender tank to do that with a flat bottom, but can be done that way. The capacity that we recommend for that would be calculated by looking at your harvest capacity, your daily harvest capacity, and the amount that the dryer can dry in that same amount of time, and then increase that by about 50%. So for example, if we have an 8,000 bushel harvest capacity in a 10-hour day, and the dryer can do about 5,000 bushels in that same amount of time, then we would have a difference of around 3,000 bushels and would say we want a wet holding capacity of at least 4,500 bushels there to make that system work better. More capacity just means you could operate through a longer delay in harvest. So if you wanted to add more to get a full day's capacity, then if you couldn't harvest for a day, you could keep the dryer running that whole day. This wet holding needs to be aerated because this grain is wet straight out of the field. We want to make sure that we're moving enough air through that it doesn't start to deteriorate while it's in the wet holding. And we would recommend at least half a cubic foot per minute per bushel of capacity in that wet holding tank. Understanding your drying system means understanding how grain drying works, understanding how different drying systems work, and then how you can manage those systems to get the most out of them. Grain drying is a fairly simple process. It involves two things. We need enough heat energy to evaporate moisture from the kernels or seeds, and then enough airflow to carry that moisture away after it's evaporated out of the seeds or kernels. And it doesn't matter which drying system you use or whether it's drying in the field or in a bin, the drying always happens by these two things. So some common systems out there, natural air, low temperature drying systems. What we do is just pump ambient air in through a perforated plenum, a perforated floor and plenum under the bin. And as that air moves up through the grain, a drying zone will slowly migrate up through the bin. This happens fairly slowly, just using ambient air because the amount of heat energy is limited. So a key point here is the grain above that drying zone stays wet until the drying zone gets there. You won't see a gradual decline in the moisture content at the top of the grain. What you'll see is it staying wet until the drying zone gets there, and then a fairly rapid decline in the moisture content when the drying zone has reached the top of the bin. This kind of drying works well for corn, for example, up to about 21% moisture most falls, but it requires a high airflow rate, 1.25 to 1.5 cubic feet per minute per bushel is recommended in our climate, and it relies on favorable air conditions for weeks of time to allow that drying zone to slowly migrate up through the bin. This drying becomes very inefficient when the outdoor air temperature drops below about 40 degrees, simply because there isn't enough heat energy in that air to evaporate the moisture quickly out of the grain. To understand how much you can dry with ambient air, you would refer to what we call the equilibrium moisture content. And again, this is frequently published in tables for different grains. This is the example for corn, the equilibrium moisture content. So here we could say if we're harvesting at 60 degrees, and have about 60% relative humidity of the ambient air, we can dry that grain to about 13%. That's the equilibrium that it would reach with those air conditions. Later on in the fall, if we're down to 30 degrees and 70% relative humidity, we're only going to be able to dry that corn to about 17% with air of those conditions. So this is part of the reason we start this kind of drying early in the fall when the air conditions are best for reaching the kind of target moisture content that we want. Incidentally, if you remember back to Ken's talk last week, if you look down that line of 60% relative humidity, it'll show you approximately what moisture content would be safe for storage at those different temperatures when we want to keep that relative humidity between the seeds or kernels in the storage below 65% to limit mold and insect activity. How can we increase the efficiency of this type of drying system? You can use what's called layer filling, where you would start by putting the wet grain in the bin in a shallower layer, perhaps just a quarter full. By having a shallow layer of grain, you'll get much higher airflow rate through that shallow layer of grain, so the drying front will move more quickly through that first grain put in the bin. When the drying front is nearly through that first layer, you could add another shallow layer of grain on top of that, and the airflow rate would reduce, but still be higher than a full bin airflow rate. So in this layered filling, you can start the drying faster in shallower layers and keep adding grain to the bin as the drying front moves up through it. That may help you to speed up the natural air drying process. Looking at high temperature drying systems, one common one is a shallow layer on the bin floor for high temperature drying. This requires about 5 to 10 cubic feet per minute per bushel, compared to the 1 to 1.5 that we were talking about for natural air drying. It takes about 2 horsepower per 1,000 bushels for the fan capacity, and that's for a grain depth of 2.5 to 4 feet deep. That depth is limited in this case to limit the difference in the wettest kernels and driest kernels coming out of this system to about 5 points of moisture difference. Temperatures typically 120 to 180 degrees in the drying air coming into the plenum, and we can usually dry about 1 to 2 batches per day at 10 points of moisture removal with this type of system. A modification of this can put the drying layer up close to the roof. In this case, you would fill over a perforated floor up close to the roof, force the drying air in to the bin and up through that wet grain to dry it. The advantage here is once that grain is dried, you can drop that grain onto the floor below and be cooling that grain down below while the next layer is drying up above. It also recaptures some of the waste heat from cooling the grain below, so it increases the efficiency both in time efficiency and in energy efficiency. With either of these types of systems, the batch on floor systems, the equilibrium moisture content for that heated air would be exceedingly low, around 5% or less. So we don't want to let the grain ever reach equilibrium. We're going to turn the dryer off long before it reaches equilibrium. What we end up with is over-dried grain at the bottom of that layer and under-dried grain at the top. If our target was 15%, we might have 12% down at the floor, 17% at the upper part of that layer, and we rely on blending of that grain when it's unloaded from the drying system to equalize the moisture between the kernels. You can help with that challenge on this layered drying by using stirring devices in the bin. The stirring devices then pull the dried grain up off of the floor and blend it back into the wet grain above. This allows us to use a thicker layer of grain because we're getting the dry grain off the floor faster, and helps to prevent that over drying that happens with batch dryers. This is the only time you will see stirring devices used, typically, is in a deeper layered batch drying system. Be aware, though, that that stirring of the grain constantly happening does create more fines that can filter down to the floor and might require some more maintenance during drying. This requires about 5 cubic feet per minute per bushel, about 5 horsepower per 1,000 bushels, higher than the shallower layer, simply because it's a deeper layer of grain, 6 to 9 feet deep typically. That depth is limited to maintain high airflow, and the stirring, the number of down augers and the speed at which they move has to be enough to get that dried grain off the floor before it's over dried. Temperature, again, about 120 to 180 degrees. And because this is a larger batch and lower airflow rate, takes about 2 to 3 days per batch at a 10-point moisture removal. Another modification of that system would be to add a tapered sweep auger down at the floor that can pull a shallow layer of grain off of the floor into a vertical auger. This way, you're pulling the dried grain off the floor and letting the wet grain from above move down to replace it. Becomes kind of a continuous flow drying system. That dry grain can either be transferred out to storage or can be put back on top of the wet grain and stay in that bin. Other types of dryers that are common out there are the self-contained dryers. One example here, you would just fill the column with grain. It's a shallow column, typically 10 to 16 inches thick. Turn on the fan and the heater, force hot air out through that column of grain. After the grain is dried, you turn the heat off and force cool air out through to cool the grain, then empty the system and start over again in a batch system. It's possible too to have these with two drying fans and a split plenum so that heated air can be moving through the top of the grain column and cooling air through the bottom of the grain column. And then you let the grain flow past it in continuous flow fashion so you can heat and cool at the same time. Another version of this would reverse the airflow through the cooling section and put it back into the heated section up above. Sometimes they call this vacuum cooling. That can increase the energy efficiency by recapturing some of that waste heat from the cooling section of the dryer. My diagrams here don't show the way the fans would be located in that case, but you get the idea. So how can we help with this kind of drying system? If you want to move to in-bin cooling, where you move the hot corn directly to a storage bin and cool it there in the storage bin, that can help with the energy efficiency and time efficiency of these systems. That cooling bin then has to be equipped with aeration that is adequate to keep up with the hot grain coming in from the dryer. So you'd need about 12 to 15 cubic feet per minute per bushel per hour of dryer capacity that you have to keep up with that hot grain coming in. The corn will lose an additional 1 to 1.5 points of moisture during drying with this in-bin cooling. So that helps a little bit with the efficiency, but you do have to watch out for condensation on the inside of that storage bin as you're cooling that hot grain. The bin needs to be equipped to handle that extra condensation. You can take that a step farther in a system that's called dryeration, and you heard Matt mention this, although not by name, last week. In here, you would move that hot grain to a bin and allow it to sit and temper, or steep, sometimes we call it, hold it hot without cooling it for 4 to 12 hours. That allows the moisture content inside the kernels to equalize more, get some more of that internal moisture out close to the outside of the kernel, and becomes more efficient then as you cool it. When that corn is cooled, you lose about another 0.25% of moisture for every 10 degrees of temperature reduction in the cooling. So typically for us, about 2 to 3 points of moisture total removed in that steeping and cooling process. It also helps to reduce stress cracks because the kernels are cooled more slowly, allows some of that temperature stress to be relieved in the kernels. You get about 25% energy reduction in your dryer and higher throughput in your dryer, 30 to 60% higher drying capacity, because you stop drying sooner, 2 to 3 points quicker than you would have if you were doing rapid cooling. Another possibility is combination high and low temperature drying. For corn, in this case, what we would do is dry to about 20% moisture in a high temperature dryer, and then move to low temperature drying bins to finish the drying. By starting at 20%, the low temperature drying is almost sure to be able to be completed yet in the fall. You get about 50% energy reduction versus standard high temperature drying. And you get a lot higher throughput on your high temperature dryer, about 3 times as much grain through the high temperature dryer, because you can stop at about 20% and finish the drying in low temperature bins. Of course, you do have to have both types of drying systems to make this work, and you have to make sure you're checking your equipment and your meters frequently to make sure you're hitting your targets. Let's talk briefly about coring bins. Sam did a good job of covering coring bins last week, but just a reminder, when you put the grain in the bin, the best kernels, the slickest, most complete and solid seeds are going to be slick and slide to the outside of the bin. The broken kernels, the fines, the other foreign material tends to accumulate in the center and not slide to the outside edges as easily. So we get this column of fines down through the core of the bin. That causes 2 problems. It reduces airflow through that core, and that core is also the tallest column of grain in the bin, which reduces airflow. And those broken kernels and fines are more easily attacked by mold, making this the most highly susceptible grain in the bin. Coring the bin, as you start to extract the grain, takes that core of grain out first as it draws down from the top of the bin. So you get the worst of the grain out of there, the highest risk grain out of the bin, and also get a more uniform grain depth to give you more uniform aeration as you aerate that bin after it's been cored. Talking about the volume that it takes to core a bin, it's about 1 to 2% of the bin capacity to core a bin. A more accurate estimate would be to take the diameter cubed and divide it by 100. So for example, a 30-foot bin, take 30 times 30 times 30 is 27,000. Divided by 100 would be about 270 bushels for a 30-foot bin to core it adequately. Let's talk about temperature control and storage. Why are we concerned about that? Remember those factors that affect the ability to store grain well. Those top two, moisture content and temperature of the grain, are a critical factor on controlling the relative humidity around the grain kernels in storage, which are a prime factor in how well mold and insects like to be active. Uneven temperature can lead to hot spots, and if a hot spot starts in the bin, the mold growth will generate more moisture and more heat, and that hot spot will just get bigger and bigger and grow snowball on you in the bin once it begins. So with aeration and cooling, we want to cool the grain for ideal conditions. We typically do that just with aeration fans, and we want to maintain even temperatures throughout the bin. We would recommend at least 1/10 of a CFM per bushel of airflow rate in order to adequately cool a bin, and running a cooling cycle about every 10 to 15 degree decline in outdoor air conditions. Airflow is the key to this. You can estimate the number of hours required by dividing 15 by your CFM per bushel that your aeration system can deliver. So for example, if you have a fairly large drying fan on the bin, 15 divided by 1 CFM per bushel would say about 15 hours to run a cooling front through the bin. With a smaller just for temperature control aeration fan that delivers 1/10 of a CFM per bushel, 15 divided by 1/10 would give you about 150 hours, or roughly 6 days expected to get a cooling front through that bin. If you don't know what your aeration capacity is, you can estimate that using the University of Minnesota FANS program that was mentioned last week. The website for it is there, and I'll put that in the chat box later. So 2 things you can do with this program. If you have a target airflow rate that you'd like to get, put in your grain and your bin dimensions and what you would like to achieve for airflow, and it'll estimate for you the fan horsepower that it would probably take. You can look at it the other way, tell it which fan and grain and bin dimensions you have, and then it will estimate for you in graphical or in table form how much airflow you should expect from your system at different grain depths in the bin. You can also do an estimate if you don't know the horsepower of your fan. You could use a small handheld anemometer to try to estimate the airflow coming through the fan. So our goal here with temperature control, in the fall, we want to lower the grain temperature stepwise in 10 to 15 degree steps until the grain temperature is down in that 35 to 40 degree range. In the winter, let's just maintain the grain temperature at that 35 to 40 degrees with intermittent aeration as needed to keep it at that temperature. And in the spring, keep the grain cool. Typically seal up the fans when the weather starts to warm up so that we don't have warm, moist air coming into the bin and starting to warm up the grain in the bin. And where the solar radiation is heating up the airspace above the grain up there under the roof, ventilate that headspace periodically to minimize that top surface warming so that top grain isn't warming back up. You saw covers made of metal last week in some photographs. You can also just use a tarp wrapped around the fan opening with a tarp strap on it to help seal up those fans. That prevents the warm spring air from getting in and warming up the grain. Also helps a little bit in keeping snow and pests out of the fan when they're not operating, and keeps that damp air away from your grain. Let's talk on monitoring just briefly here. You can use your nose to monitor grain condition by smelling the odor of the air that gets flushed out of the grain when you first turn on an aeration fan. With a big drying fan, that first flush of air might come out in as little as 30 seconds from the grain. So it might take two people, one up top ready to sniff that air and another to turn the fan on. With a smaller aeration fan, that might be 5 or 6 minutes to flush the air out. A single person might be able to do that on their own. You can also watch for temperature increases. Temperature probes or temperature cables in the bin can give you an indication if there's a temperature rise, which would indicate insect or mold activity. And even just probing the grain with a temperature probe or a steel rod might help you identify a wet spot that has started to mold. It'll feel sticky when you probe it rather than slick. So that sour or musty smell is a good indication that there's mold growth starting somewhere in that bin, but you don't know exactly where. A better way to measure that is with a carbon dioxide monitor. Carbon dioxide generated by the mold growth or insect activity will start rising before any noticeable odor is there. These monitors are not terribly expensive. They can get them from $50 to $500, but for the kind of accuracy we need here, 100 to 150 will get you a monitor that will be quite usable for this. A reading under 600 parts per million indicates things are in good condition there. If it gets over 1,500 parts per million, that indicates a serious activity of mold and insects or insects in the bin and time to take action and get something changed. So our overall objective here for dry grain, control the temperature down around 35 degrees, check it every week or two, use caution, of course, when you're entering bins to check the grain, and have a plan for moving the grain if any problems develop. If that grain isn't completely dried, so for corn, if it's 15 to 20% moisture, you can control the temperature down to around 35 degrees and check it weekly, and it'll probably store okay through the winter, but you need to finish drying or move that grain before mid-spring, because even though that'll store at a cold temperature, when warm temperatures return in the spring, mold growth will resume if you don't get that dried or out of that bin. So in spring and summer, if you're going to store all the way through spring and summer, that grain has to be dry. You just can't store wet grain through the spring and summer temperatures. You're bound to have trouble. The insect activity will return even if the grain is dry, if the temperature is too high. So we'd like to keep that grain temperature below about 50 degrees Fahrenheit. There was mention last week about wanting grain to be warmer for some processes, some processing that you might want to do. But if that's the case, I would say don't warm that grain until right before you are going to be processing it. Otherwise, keep it cool. About 50 degrees Fahrenheit is a good target, and just keep it there through the warm weather. Of course, we want to be paying attention to safety here. If you're going to enter a grain bin, make sure the grain surface looks right. If any grain has been removed, make sure you see evidence of that inverted cone. Otherwise, there could be bridged grain over a hollow spot that could collapse and trap you. Use a partner and a safety harness if possible anytime you have to enter the bin, and use proper respiratory protection, especially around grain that is losing condition and may have additional dust and mold spores present. And always stay out of flowing grain, lock out and tag out any unloading equipment before you get in the bin. You can also manage to add safety kind of in a preventative fashion here. Things like making sure there's access for emergency equipment if needed in and around your grain handling operation. Make sure there's space and walkways for maintenance to minimize the use of ladders and climbing and reaching. Protect power lines from tall equipment like augers that you're moving around and grain trucks, fall prevention equipment like ladder cages, stairs, landings, and railings can greatly reduce the number of slips and falls, and that's still the #1 cause of injuries in grain handling operations is slips and falls. Use the lockout and tag out equipment on any power to unloading equipment or any power equipment inside the bin so that you can make sure that none of that is energized while someone is inside the bin. And make sure signage and hazard marking is all clear and legible so everyone knows how to turn off equipment, where the power is for everything, where the safety hazards are. And grain quality protection is a big part of safety, because grain that has gone out of condition will cause people to do things that are dangerous, like getting in and trying to break up bridged grain. Keeping the grain in good condition is in itself a good safety measure. And finally, backup plans. The best grain managers have a backup plan because things can go wrong. You need to monitor weekly to catch problems early and know what you can rescue and what you need to just unload and move out of the storage. Have a plan for who can take bad grain, where the market would be for grain that has gone out of condition, and then don't hesitate. A problem ignored will get worse, not better. So have a plan, be ready to enact it, and don't hesitate when things start to go wrong. And as always, call for help when it's needed. Here are a few of those grain resources I mentioned. The Grain Drying, Handling, and Storage Handbook from Midwest Plan Service is excellent. Natural Air Corn Drying in the Upper Midwest is a handbook from the University of Minnesota that has some fantastic information if you want to do natural air drying. There's good information at the University of Minnesota corn harvest pages, which I've listed there, and also from the Iowa Grain Quality Initiative at iowagrain.org. And with that, I think I am through those slides, and we'll add that website for the fans program to the chat box and open it up for questions, Aaron.
Okay, we do have a question in the chat box. I'll read it to you. When do you want to stir the grain when drying with stirrers? We dry with lower plenum temperatures, 110 to 120 degrees. Should we run the stirrers for a few hours each day when drying?
I think the answer to that depends on how deep the layer is. If it was a shallow layer of grain, less than 4 feet, you could stir it just to get good airflow through there, and then let the batch drying start to take place, wait, and then stir it again later. If you're putting heat to a deeper layer, though, you probably want to stir that almost continuously. It depends on the drying rate and how dry that grain is going to get before the stirring device can get back to it. You don't want to over dry that grain before the stirring device could get there. So talk to the equipment supplier, look at the information in the manual for the stirring device on how quickly it brings the grain up off the floor, and it all boils down to the point of stirring is to get the grain off the floor before it's over dried, and you need to balance that with the drying rate. It will take less frequent stirring at the lower temperature, but the other caution with low temperatures here is you don't want to slow down the drying so much that there's a risk of spoiling the grain before it can get dried.
Good. So it seems like as you kind of have to do a little experimentation and take moisture samples to see how fast that layer is actually drying, and then you can gauge how fast those stirrers should go.
Right.
So here's another question. There we go. What is the best way to deal with condensation that may form on the inside of southern exposure of the grain bin?
If there are a couple of ways to do that. There are some grain bin manufacturers that will supply air tubes that channel extra air from the drying floor up the wall of the bin and distribute it out along that grain at the edge of the bin. So you can try to do that by adding a little extra airflow out there to evaporate that moisture after that condensation has formed, to try to keep that grain drier and better aerated. If it's in a system where you are doing in-bin cooling, dry aeration, for example, we typically would recommend, if you know you're going to get a lot of condensation there, to just move that grain out of that bin after it's cooled. Then the mixing, when it's being transferred out, will help to blend that re-wetted corn back in with the dry corn, for example, as it's being moved. Otherwise, probably the best solution would be to have the wall of the bin insulated, but that's excessively expensive and you almost never see that done. But you do get that condensation forming, and you also get that heating on the south wall of the bin, so that grain won't stay cool as well as you'd like. There, about the only thing we can do is some periodic aeration if that grain starts to warm up too much. The advantage that we have is that grains are good insulators. So as that wall of the bin warms up, that high temperature isn't going to travel very far into the grain mass. And by the time you get a foot away from the wall, the grain insulation is enough that it will stay fairly cool farther in from the wall.
Okay. So back to drying with stirrers. How do the stirrers affect the drying front? Especially if everything's drying all at the same rate.
Yeah, stirred drying, what we do is disrupt the drying front. So we don't have an actual drying front moving through the bin in the same fashion. The stirrers are constantly disrupting the drying front and blending the dried grain back in with the grain above. So in this case, we have a stirred batch of grain, and the moisture content on it will be kind of slowly declining in the entire bin because we've taken the dry kernels off the floor and blended them back in. So here you'll have a drying front right down at the floor that's trying to form repeatedly, but we're constantly breaking that up and pulling that dried grain back up and blending it with the grain above. If I didn't answer what they were asking there, ask again, and I'll try again if I wasn't understanding the question.
Okay, so we have another question. Would the drying dynamics you described for corn be similar for drying beans? Any particular differences to be aware of for soybeans? Or wheat? We have, folks growing wheat as well.
Sure. Corn and wheat, probably more similar than corn and soybeans. All grains are going to follow the same kinds of drying principles and procedures. One thing to note with soybeans is that the soybean seed coat is particularly sensitive to low relative humidity drying air. If the relative humidity of the drying air is below 50% or so, you'll get more splits forming in soybeans as they're being dried. So we typically try to dry soybeans with relatively low temperature and watch the relative humidity of the air after you've heated it, and try not to get it too far below 50%, or you're going to end up with more splits than you would have if you had kept that relative humidity of the air just a little bit higher for soybeans.
Okay, so I wasn't too accurate on that question. Would soybeans be the same as dry beans? Like turtle beans and black beans and.
Yeah, and here you've got me at a disadvantage because I'm from Iowa and we don't grow many beans other than soybeans. So I'm afraid I suspect that there would be a lot of similarities there, but I'm not certain about that. And if Sam is on the call, if he wants to weigh in on that, he may be far more familiar with that than I am.
We'd have to unmute Sam. So Sam, you'd have to raise your hand so we can allow you to talk.
I got him.
There we go.
Sorry to put you on the spot, Sam.
That's okay. No problem. Check one. Can you hear me? No, we we have the major crops as well here, Shawn. Corn, wheat, soybeans. I know Ken Hellevang has done some work with some specialty crops, field peas, and I think I got dropped there, but yeah, no, I think I would look to maybe to Ken Hellevang in North Dakota State for some of that information. The similar to what Shawn was showing there, I mean, each grain, of course, has its own equilibrium moisture content chart, and that would be a starting point, I think, to look at guidance on other crops that we have not talked about.
So I'll just make a comment about that too. So dry beans are pretty large in size, and so that moisture has to migrate from the center of the kernel to the outside. And if that happens too fast, I think that's when you get cracking as well. So you have to probably dry beans have to be dried a little bit more gently and slowly than a smaller size kernel.
I say that would be correct. And for soybeans, we recommend not going below 40% humidity in your drying, so that it's not over dried. Back to some of Shawn's points. And yeah, most of the food grade corns, same thing. You want to dry them with lower air temperatures, and maybe some of the, if there are any farmers from the panel last week, hopefully they could maybe chime in on some of their experience. But with food grade grains of any type, lower temperatures, it's a little slower drying times, higher drying humidities that to keep from over drying.
Thank you, Sam.
Does anyone else want to raise their hand or type some questions in?
See, there's a question there about, is there a real advantage to screening the grain before putting it in the dryer or bin? Should we do that before drying or after drying? There was a little discussion of this last week as well. There are advantages to screening before it goes through the dryer, just to increase the drying efficiency, reduce the amount of fines that accumulate in the drying system, especially if you're talking a batch on the floor bin dryer where you're running multiple batches on the same drying floor. Having additional fines in there just starts to reduce the airflow, starts plugging up the drying floor. So in that case, screening before you go into the drying system would have some advantages. But I think the primary advantage is making sure the grain is cleaned before it goes into storage, or alternatively, coring the bin at least to take out some of the worst of the fines and broken kernels after it hits the storage. It's the problems that those fines cause in storage that we're mainly concerned about here. So I would say at the very least, it's good to make sure that the grain is cleaned or the bin is cored in storage. Beyond that, depending on the drying system, there may be enough advantage to be worthwhile doing that before it goes into the dryer. But then thinking back to something that Matt mentioned last week in the farmer panel, the best thing to do is to watch for damage at harvest and try to reduce the amount of damage before the grain even gets to your drying system. Matt mentioned checking the loads that were coming in, but by the time you would get word back to the combine, there might be 2 more loads on the way. It's best if the person operating the combine is checking the grain tank with each load to see if there's excessive damage happening during harvest that can be eliminated before it ever gets to the grain handling system.
Okay, there's another question in the chat. You mentioned cooling grain to store over summer. That's just ambient air at night, I guess?
Yes, in our climates, we would cool the grain in the fall, early winter, get it down to our target temperatures and try to keep it there as long as we can. If it starts to warm up because of sunlight on the storage container, or other things like that, or you didn't get it cooled when you wanted to, you could watch for cool nights to try to cool that grain, but it would take a large capacity aeration system to cool it in a single night. So you'd have to watch that, and also be aware that at night we typically, at least in the spring and in the fall, nighttime relative humidities typically go up to very close to 100%. So you'll be cooling with some rather humid air if you're just doing nighttime cooling. That's why we really like to see the grain cooled in the fall and early winter, when you can do that with relatively dry, cool air.
So some of our participants here have small systems. So in a grain bin, grain is an excellent insulator, and it's going to stay cool. But if I have grain in sacks, 1-ton totes or 50-pound bags, or if I have a gravity.
So we lost Aaron. I think I know where he was going with that question. Yes, in much smaller containers, yeah, the grain temperature is going to change more rapidly. So yes, if you're storing in small totes or bags, the grain temperature may come back up, and then using some of that nighttime air to cool things back down again does make sense. So just monitor that. And if the grain is fully dried and in good condition, it will store better at those warmer temperatures. But certainly if the grain has any condition problems to start with, or wasn't fully dried, then that temperature control is even more critical. But controlling the temperature with some nighttime aeration, especially in those smaller containers, should be fairly effective.
Well, people are thinking of their questions. I'm going to ask one of mine, and that is sometimes, we don't want to run a fan on a rainy day or a humid day or a humid night. And so sometimes farmers are turning fans on and off for a few hours at a time. So I know Ken Hellevang up in North Dakota recommends keeping fans on kind of constantly because the temperatures and humidities average out over a day. So can you shed some light on that?
Yeah, I like the way Ken describes that. And two different things here. For a drying front moving through the bin, if you're using low temperature drying where you need the fan to run for multiple days or weeks, we would recommend not turning that fan off even on a day when it's raining. Reason for that, twofold. Number one, when the air moves through the fan, you're going to pick up a little bit of heat in a little bit just in compression of the air, in the pressure change, but also from waste heat from the fan motor. You're likely to pick up 2 or 3 degrees of temperature as it moves through the fan. That 2 to 3 degree increase in air temperature will bring the relative humidity back down off of 100%. So what actually reaches the grain is not going to be saturated air anymore after it's gone through the fan. The other thing is, remember that hot spot possibility. If you turn the fan off while there's a drying front trying to move up through the bin, now you've got stagnant air sitting there on that moist grain, and that's just a recipe for encouraging mold growth to start. So we like to keep some air flushing through that grain, even if it's not drying the grain in that overnight period or in that wet day. Having the air moving through the grain helps to prevent any mold growth from starting and that snowball effect from starting in the bin. So for those two reasons, we would keep it moving all the time for a drying system. Now, if you're just removing a cooling front through the bin, it's maybe a little less critical, although if the grain that has cooled overnight at the bottom of the bin, the next day, if the air temperature warms back up, that warm air moving in there is going to be cooled by the cool grain in the bottom part of the bin. So there's still some benefit. You're going to help move that cooling front a little bit, even though the outside temperature fluctuates up and down. So typically I'd say just go ahead and let it run unless the forecast says you're going to get 2 or 3 days in a row that are above your target temperature. But the daily fluctuations, I wouldn't worry about too much. Now, having said that, there are companies that are coming up with controllers for fans, smart controllers that will try to squeeze every little bit of efficiency out of the system by doing just that. They may not turn the fans off completely, but may reduce to a lower ventilation rate when the target temperature isn't right or the humidity isn't right. So there's some automated systems out there that may be able to squeeze every last bit of efficiency out by doing things like that. And you can do that manually as well. But for most folks, I think the penalty for just letting the fan run probably doesn't justify the added management requirement of trying to do that.
Okay, Christian, I might need your help because my Q&A is disconnected from me for some reason. So I'm not
I
sure.
got it. There's nothing in there right now.
Okay.
Sean,
right,
I
wait.
did have a question for you. In the mid and lower Hudson Valley region, we have people that have smaller drying systems, and sometimes they use the digital humidistats that plug in, and then they'll kick the aerator fan on, whether they're doing a small bin or even drying in super sacks, just to keep it's sort of where they want it to be on the drying, and they're just trying to keep that humidity out of there. Are there any disadvantages with that?
No, I don't think so. As long as the humidistat works properly, that is kind of a bit of a smart controller to say, I'll go ahead and aerate a little bit more anytime the air conditions are just right for aerating. You'd want to couple that with the temperature too, to make sure that you don't run temperature in a direction you didn't want it to go, along with humidity. But there's some possibility there, yeah, of some additional benefits by controlling aeration and not putting moisture back into the grain inadvertently. It doesn't happen as fast as the moisture comes out for most grains. So the downside, or the penalty for aerating with air that's a little higher humidity than you wanted isn't as great as you might think, because the grain doesn't re-wet as quickly as it dries in most cases.
Any other questions? I have one more. When we talk about not going into bins or working in dusty areas to have proper respiratory equipment, does that include the face masks we use for COVID, or do we need something a little more substantial?
I think for most cases you want something better than that. I mean, a dust mask is a help, and will help get some of the large particles out that might annoy you. But the things that we're really concerned about are the particles that are finer, that get deeper into the lungs and cause more serious health threats potentially. And those need a little better filter than what we typically see in the single band face masks, or even the 2-band face masks that are so common right now. The other thing to keep in mind for protecting your lungs is fit is critical, and that's true all the time in any kind of respiratory protection. The fit of the mask to your face has to be right. If the mask doesn't fit tight against your face, you're getting the air bypassing the filter and really negates the benefit of the filter. So it's worth spending some time trying on different face masks, a half mask or a quarter mask. Find one that fits your face really well, and then look for the proper kind of filter media to go with that mask to take out those finer particles, mold spores and things like that would get through a lot of inexpensive throwaway dust masks.
Okay, great.
And we did have a raised hand. Mary Corey, did you want to ask your question? You are unmuted if you would like to ask. Might have already got her.
I just wanted to say I mistakenly hit that button. Sorry about that.
Okay. Yeah. Sorry for putting you on the spot.
All right. Okay, it's 12:01. Thank you very much, Shawn. That was really good. I got a bunch of notes here.